Brake linings are the consumable surfaces in brake systems, such as drum brakes and disc brakes used in transport vehicles. History. Brake linings were invented by Bertha Benz during her historic first long-distance car trip in the world in August 1888. The first asbestos brake linings were developed in 1908 by Herbert Froude. Although Froude was the first to implement the use of asbestos brake linings, the heat dissipation properties of the fibers were tested by various scientists, including well-known materials chemist Dr. Gwilym Price, who did most of his research and testing from Cambridge, United Kingdom, and various Cambridge-funded institutes. Structure and function. Brake linings are composed of a relatively soft but tough and heat-resistant material with a high coefficient of dynamic friction, typically mounted to a solid metal backing using high-temperature adhesives or rivets. The complete assembly is then often called a brake pad or brake shoe. The dynamic friction coefficient micro for most standard brake pads is usually in the range of 0.35 to 0.42. This means that a force of 1,000 newtons on the pad will give a resulting brake force close to 400 newtons. There are some racing pads that have a very high micro of 0.55 to 0.62 with excellent high temperature behavior. These pads have high iron content and will usually outperform any other pad used with iron discs. Unfortunately, nothing comes for free, and these high micro pads wear fast and also wear down the discs at a rather fast rate. However, they are a very cost-effective alternative to more exotic, expensive materials. Using a typical bicycle brake as an example, the backing would be the metal shell which provides mechanical support, and the lining would be the rubbery portion which contacts the rims when the brakes are applied. In most modern vehicular applications, the system is conceptually identical, except the rims would be replaced with solid steel disc. Furthermore, a metal tang is usually incorporated into the pad assembly. The tang contacts the rotors when the linings are worn out, causing an annoying noise designed to alert the motorist that brake servicing is required. Since the lining is the portion of the braking system which converts the vehicle's kinetic energy into heat, the lining must be capable of surviving high temperatures without excessive wear or outgassing. Due to its efficacy, chrysotile asbestos was often a component in brake linings. However, studies such as a 1989 National Institutes of Health item showed an uncommonly high proportion of brake mechanics were afflicted with pleural and peritoneal mesothelioma, both of which are linked to chrysotile and asbestos exposure. Public health authorities generally recommend against inhaling brake dust. Chrysotile has been banned in many developed countries, such as Australia in late 2003, and chrysotile has been progressively replaced in most brake linings and pads by other fibers such as the synthetic aramids. Maintenance. When the lining is worn out, the backing or rivets will contact the rotors or drums during braking, often causing damage requiring remachining or replacement of the drums or rotors. An annoying squeal caused by the warning tang is the typical alert that the pads need to be replaced. If the squeal is ignored for too long, drum or rotor damage will be the typical result. The lining may also become contaminated by oil or leaked brake fluid. Typical symptoms will be brake chatter, where the pads vibrate as the lining grabs and releases the rotor's surface. The solution is to repair the source of the contamination and replace the damaged pads. In the automotive repair industry, many consumers purchase brake pads with a lifetime warranty. These pads use a much harder lining than traditional brake pads and tend to cause excessive wear of the much more expensive rotors or drums. For that reason, consumers should ensure that the new brake pads installed are those specified or supplied by the vehicle's manufacturer. Reline brake pads are usually inexpensive and perfectly acceptable, with new lining material attached to reconditioned backing assemblies. Brake pads must always be replaced simultaneously on both ends of a vehicle's axle, as the different lining thicknesses will cause uneven braking, making the vehicle pull in the direction of the more effective brake. For most vehicles, replacing pads is very easy, requiring a minimum of tools and time. The linings are designed to be consumable and should therefore be easy to service. Brake linings can also be found just about everywhere there are braking systems, from elevator safety brakes to spindle brakes inside a VCR. The form and materials are frequently different, but the principle is the same. Cataloging. There are different systems for the cataloging of brake linings. The most frequently used system in Europe is the WVA numbering system.